Today we discuss first electric cell. What is electric cell? All of you know cell represented by this symbol. Cell, generally the dry cell we use, it has one positive, one negative end. So what is electric cell? The electric cell is a source of electrical energy which maintains a continuous flow of charge in a circuit. Means in a circuit, if you connect a cell, then there will be continuous flow of charge through the circuit, which is not possible without this cell, and it maintains the flow of current. Now let us discuss what is the meaning of EMF of a cell. All of you know EMF means potential difference. EMF means electromotive force. What is electromotive force? It is a type of potential difference, of course. Suppose this is a cell which is connected to a resistor. What is electromotive force? It is the work done to shift unit positive charge one round through the external circuit as well as inside the cell. Means how much work a +1 coulomb charge need to do, or how much energy should be supplied by the cell to this +1 coulomb charge so that it can travel throughout the external circuit as well as through the electrolyte inside the cell. So this is called EMF of the cell. If we consider dq charge need dW joule of work, or dq charge need dW joule of energy to travel one round through the external circuit as well as through the electrolyte of the cell, then EMF of the cell E is denoted by dW divided by dq. So this is the meaning of EMF of the cell. dW is measured in joule, dq measured in coulomb, and joule per coulomb is called volt, which is represented by V. So EMF of the cell, you can understand it is work done per unit charge. But here you have to remember the work done or energy supplied to move the charge through the external circuit as well as through the electrolyte of the cell. Next we are going to discuss terminal potential difference. Next we are going to discuss terminal potential difference. So what is terminal potential difference, you understand? Terminal voltage or terminal potential difference. Terminal voltage or terminal potential difference. Let us assume a cell is connected to three different resistors. Say R1, R2 and R3. These are three different resistors. This is R1, this is R2, this is R3, connected to a cell of EMF E. Now let us assume the work required to overcome this resistance is dW1, this resistance dW2, this resistance dW3, and these are the 3 points. Let us assume that V1 is the potential difference across the first resistance, V2 is the potential difference across the second resistance, and V3 is the potential difference across the third resistance. Now you can see this cell has to supply energy so that the charge can cross these three resistances. If the charge is dq and if this dq charge need dW1 joule of energy to cross the resistance R1, dW2 joule of energy to cross the resistance R2, and dW3 joule of energy to cross the resistance R3, then dW1 divided by dq, that is called terminal voltage or terminal potential difference across the resistance R1, dW2 divided by dq, that is known as terminal potential difference across the resistance R2, and dW3 divided by dq, that is called terminal potential difference across the resistance R3. So V1 and V2 and V3 are represented by dW1 by dQ, dW2 by dQ and dW3 by dQ. Now let us understand what is the internal resistance of the cell. What is the meaning of internal resistance of the cell? And what are the different factors on which the internal resistance of a cell depends? Let us consider this is a cell. This is a cell which is having, this cell has this internal resistance R. And it is connected to a voltmeter, and this is connected across a key, a external resistance capital R, and an ammeter A connected to the circuit. Now whenever you switch on the circuit, then what will happen? The circuit, through the circuit the current will flow, because cell is supplying current. But due to the electrolytes present in the cell, the resistance is offered by the cell. So we can say the resistance offered by the electrolyte of the cell to the flow of current through it is known as internal resistance of the cell. Now this internal resistance of the cell depends on few factors. First, it is directly proportional to, first, internal resistance of the cell directly proportional to separation between the electrodes, This is the first factor. Okay, these are two electrodes and internal resistance is directly proportional to the separation between the two electrodes. It is inversely proportional to the plate's area which is dipped inside the electrolyte. For example, suppose this is a cell and this much is the electrolyte. This is one plate and this is another plate. So what area of the plate is inside the electrolyte? It depends on this factor, and how it depends? Inversely proportional. It also depends on the nature, concentration and temperature of the electrolyte, and it is increases with the increase in concentration of the electrolytes. So these are the three factors on which the internal resistance R of the cell depend. If the cell supply the energy, total energy dW, this energy is divided into two parts. One is dW external, and one is dW internal. dW external for external circuit to overcome the resistance of the external circuit, the energy required is dW external, and dW internal is the energy required to overcome the electrolyte, the resistance which is given by the electrolyte of the cell. So total work done dW is equal to dW external plus dW internal. So dW external, what is that? We know E equal to dW by dQ. And what is dW external? dW external, this is, so dW equal to E dQ, and we know dQ is equal to I dt because we have the relation I equal to dQ divided by dt. So dW is equal to EI dt. Now what will be dW external? dW external is due to the external resistance, so it can be written as VI dt, where V is the terminal voltage. It is VI dt. And dW internal, it is for internal resistance of the cell. So internal resistance of the cell, it can be written as V is equal to, if it is a potential drop, it is I into R. V equal to I into R. So I into R, if we take, then this will come I square R into dt. Okay. So what is the equation we get now? dW is equal to dW external plus dW internal. If we put this value, then we get EI dt is equal to VI dt plus I square R dt. Okay, so dt if we remove and I if we remove, then we are getting E is equal to V plus I into R. So EMF is equal to what we get, terminal voltage plus I into R. So I into R equal to, you can write E minus V. So what is R? R equal to E minus V by I. Also Ohm's law states that I equal to V by R. So if we put this value in this equation, then we get R equal to E minus V divided by V by R. So that is E by V minus V by V into R. So that is E by V minus 1 into R. So knowing the value of EMF of the cell, internal resistance and external resistance, knowing the value of EMF of the cell, terminal voltage and external resistance of the circuit, the internal resistance of the cell can be determined.